Hello, everybody. This is Nick Totaro, Professor of Information Technology and Computer Science, Lakeland Community College, and this is Network Forensics. Um, in other videos, we talked about network forensics relies heavily upon logs. But again, we need to understand basic networking things so we can understand what logs are being generated and what logs we can look at to gather particular information. Let's talk about how we discover things. When I go up to the internet and I go to my browser and I type uh, www.wikipedia.org, right? What goes on there? Well, by now you should know that is a DNS lookup, domain name services lookup. And how that basically works is fundamentally how it works. There's a lot of things to speed things up here, but we're just going to talk about fundamentals in this video. I go to my browser, I type www.wikipedia.org. That goes up to my initial DNS server. Now, that initial DNS server is obligated to return something back to me, right? I've basically forced that DNS server to provide something back to me. Either give me the IP address of wikipedia.org or tell me I don't have an IP address, you might have screwed up, right? So it's obligated. But let's say I go to my initial DNS server and it does not have the address for wikipedia.org. What happens? That DNS server, it will go out to other DNS servers and it will ask those other DNS servers. The first one it will go to one of those top level 13 DNS servers. It'll go to the .org DNS server and say, hey, do you know who wikipedia.org is? Now, the conversation between those two servers, they're under no obligation. The .org server, the root server that maintains the .org, it may not know, right? It's under no obligation. So it may send back, I don't know, but I know a server that might know. Remember, we're looking for a very specific server. We're looking for www. We're looking for the World Wide Web server for the wikipedia.org domain. So the .org root server sends back, I don't know, but I know somebody that might. They're going to send back the DNS server for the wikipedia.org environment. So now my initial DNS server goes out to the wikipedia.org DNS server or who's ever managing the DNS database for wikipedia.org. It goes to that DNS server and say, do you have the IP address for www.wikipedia.org? And who's ever managing it, we'll assume Wikipedia has their own DNS environment. They'll say, yeah, here is the IP address for that particular environment. Now, let's go out to my machine. And here's a brief breakdown of what I was saying. This initial DNS server, that's who I, as a user, contact. They basically go out to the different DNS servers, and then eventually whoever is maintaining the wikipedia.org environment responds back to my DNS server. Now my DNS server can go back to me and says, here is the IP address for wikipedia.org, for the www server at wikipedia.org. What happens if I make a mistake? What if I type? You guys know by now, my typing skills are horrendous. I go and I mistype. I do a let's make some wwq.wikipedia.org. It still has to go through the whole process again. But this time when I hit my server, I say, can you tell me who wwq.wikipedia.org is? That server has to start the whole process again because between me and that server, there's an obligation to return either an IP address or couldn't find it. It has to try its best. It goes to the root level domain, says, do you have a server wwq.wikipedia.org? No, but I know somebody that might. So it keeps sending me, and eventually it will hit the domain name service that's ever managing the addresses for Wikipedia and says, do you have the IP address for www.wikipedia.org. And that server says, no, that's not in existence. That doesn't exist. I don't know what you're talking about. So now that sends back a could not find, doesn't exist. It doesn't say that I'm an idiot and I mistyped it. It says, no, that server doesn't exist. Now my DNS server, the first one, it's going to fulfill its obligation. It's going to kick back to me and said, couldn't find it. Remember, there's an obligation between my browser, my device, and my DNS server. Now, if you haven't taken the 1205 course, or specifically you haven't taken the 1205 course with me, you probably weren't aware of all the different things that could potentially speed this up. Again, that's for the Networking Plus course. There's a lot of ways that we can speed up this whole process. We could have DNS cache, which is important inside log files. We could have host files. We could have individual DNS cache on our machine. The DNS servers can have cache. We have cache-only DNS servers. It's a wide variety of things. But for what we're talking about in log files, we're fine. Now, let's go back up to my machine now, and let's look at a Zeek log file for DNS. Should have done this first. It was already there. Let me switch this around a little bit. There, make it a little more readable. Alrighty, inspecting a DNS log. There's really not a lot that's going to be inside the DNS log. Yes, we're going to have a date and timestamp. And again, the date and timestamp is based upon a Unix date and timestamp. And we can clear that up with going to a Unix command. I'm not a Unix expert, and say, okay, what is the date and time associated with this particular date and timestamp? And if we scroll down, I think this one was in previous videos or in other videos, I think it was June 2028. Then, similar to other videos, then what we have is a unique identifier for this particular session of a DNS lookup. I'm sitting at a server, I'm sitting at my browser, and I'm requesting information from that initial DNS server. We have the unique identifier. In Zeek, I know this is not a Zeek course, but in Zeek, that unique identifier, I can look at other log files. Oh, this particular unique identifier corresponds to this log file, maybe for connections or FTP or something. We have the initiating server, the initiating client browser, that's at 192.168.476, and we have a responder. Now, we can immediately tell that the responder is on the same network. That's common. It's very common in organizations that the first DNS server that you contact would be your company or your organization's DNS server. It's a common practice because DNS is not just what we use to find information on the internet or devices or services on the internet. It's how we find devices throughout our entire network. So this is telling me that the DNS server on this network, the DNS server is on this network. It is using port 53, which is the DNS port. It is using UDP. In other videos, we talked about connection-oriented protocol versus connectionless-oriented protocol. User datagram protocol is a connectionless protocol where we send requests and it streams the information back. If we lose a packet or two, we're fine. Something like sending back just digits, numeric values, that doesn't take hypersensitivity. So it does make sense that using UDP in this particular environment. It does say, okay, you returned the query of testmyids.com. So on that DNS server, there appears to be a DNS zones or the DNS database for testmyids.com. And then there's different classes and cards that are associated with DNS. If you're interested in DNS, obviously take Networking Plus with me. Shameless plug. But we talk about the different types of records inside a DNS server. We have server records, we have um, mail records, we have a whole, if you need to find a service on your network, you go to DNS. So that is basically what's happening here. We have a date of this request. We have a unique identifier of this connection, this DNS connection. We have the originator, the browser, somebody did something. We have the responder. By basically looking at the IP addresses that are associated there, we know that the DNS server is on our particular network. We know what port we're using, 53, that's a standard port, and we're using a connectionless protocol. I know we covered a lot with DNS, but it is important that we understand basic networking. It's like everything else in forensics. We have to have a basic understanding of the technology. As we get more deep into certain subject matters, then of course we need to understand those subject matters in a more comprehensive approach. So what did we do in this video? We basically went to a browser, we did a lookup, and there was a log file that was associated with it. Remember, most network forensics is about looking at log files. That being said, let's go learn something.